So last year in Science 10, you dealt with scalar and vector quantities. But you only dealt with what we would refer to as one-dimensional vectors. Okay? They were positive or negative, or they were forward and backward, or north and south. They were always exact opposites, and that's as complex as you got. Okay? We often also refer to those as collinear vectors because they're on the same line. All right? So we'll start out kind of reviewing how those work and using that to figure out what the fundamentals of vector addition are before we start having to add two-dimensional vectors, which means we would have angles. Okay, so it would be like 10 degrees north of east and then 50 degrees south of west, and we would have to figure out where that object is in kind of a two-dimensional XY kind of scatter plot. Okay, so we'll be looking at that kind of stuff moving forward here. So today we're just going to look at collinear vectors as a review and as how to draw vectors, how to make a proper vector diagram and things like that, because that's going to be the fundamentals for more complex vector addition as we go along. All right, so collinear vectors, what are they? They're vectors that are on the same line. Okay, they share a line, so they're one-dimensional. Okay, all types of vectors are added by placing them tail to head. Okay. That's how we draw all vectors, and I'm going to explain that in a little more detail in a few minutes. Okay? Understand that vector quantities obviously have magnitude and direction. We've gone over that already. Okay? And understand that all vector quantities are added the same way. So once I teach you how to draw vector diagrams, you use that for any vector quantity. Displacement, velocity, acceleration, force. All of them get drawn the same way. Any vector quantity is drawn as an arrow, and they're drawn tail to head. Okay? All right. So if we have, let's say, a very simple vector like what we see here, okay, it would have a vector quantity, sorry, we would have both magnitude and direction, right? So we would draw that as an arrow. The arrow can represent both of those factors, the magnitude and the direction, okay? We represent the magnitude of the vector quantity with the arrow's length, right? So if I have a 1 kilometer vector and a 2 kilometer vector, the arrows I would draw would be different, right? One of them would be half as long as the other. We use the size of the arrow or the length of the arrow to represent the magnitude of the vector quantity. Okay, everyone follow me on that? Okay, pretty straightforward there. Okay, and then because it's an arrow, we can make it point in the direction that we were given for that vector. So in this one here, right, this one would say this is a 2 kilometer vector at 30 degrees, because we have a compass here, north of east. Okay, because it's above or in a northerly direction from due east. Right? So this arrow, this is how we would represent any vector. Draw the arrow, okay, and then draw it in the direction that it is pointing or supposed to be pointing. Okay, so the big thing here, okay, the direction of the arrow gives the direction of the vector. Okay, that's super important. And then on the next slide here, okay, the length of the arrow is proportional to the magnitude of the vector. Right? So a 4 kilometer vector would need to be drawn twice as long as that arrow was. Okay, questions on that? That's the fundamentals of all vector addition. How to draw a vector. That's how you draw it. Okay? Now, if I have more than one vector, then I have to draw them like I'm telling a story. Right? So if the story went like this, okay, a car goes due north for 2 kilometers, I would draw, okay, an arrow that's 2 kilometers long going due north. And then it says it turns and travels due east for 1 kilometer. Where would I draw that vector?
In the top of your arrow.
Exactly. I would put the tail of the second vector on the head of the first, okay, because I'm telling the story. First it did this, and then it did this. Okay? Everyone follow me there? So my total displacement then, okay, would be that side of the triangle. Right? Remember, displacement is how far and in what direction you are from your starting position. That's what the blue arrow would represent. Okay? My displacement in a straight line from where I started. Would it be pretty easy to calculate this number?
Yes.
Yeah, I just use what? Right, I use the Greek geek. Okay, I studied triangles his whole life. Okay, Pythagorean theorem. Okay, that'll get us the magnitude of this. How would I get this? How would I get theta? Because remember, displacement's a vector quantity. I need to know not just how long that arrow is, but what way it's pointing.
Would you use trigonometry?
I would use trigonometry. Okay? Now, in this case, I'm looking for this angle, and I know the adjacent side and the opposite side. Which trig function would that be?
10.
10. Okay? You're going to have to use this. Okay, so get the one. We're going to use simple trigonometric ratios to solve these kinds of problems. Okay? Nothing terribly difficult, but you're going to have to use trigonometry. Incidentally, you would probably want to take this opportunity to double check your calculator is in degree mode. Because sometimes in math you use radians, and if you are in radians and trying to do physics, you're going to get ridiculous answers because radians treats numbers differently than degree does. Okay? So hit mode, sorry, on your calculator, okay, make sure it's on. Hit mode and make sure that it is in degree mode. Mine wasn't. So, okay, go over to degree, hit enter. All right. And then you can check and make sure it's in degree mode by going sine of 90. If it doesn't say 1, you're in radians. I don't know what it says, but it says something other than 1 if you're in radians. Okay, so make sure. Okay, so lots of times, like we just said, it's necessary to add two vectors. The simplest form of vector addition is collinear vector addition, which is this. Okay, so we have this question set up here. Okay, first the car moves 275 meters due east along a straight line, and then it moves 125 meters due east. Right, so here's our 275 meter vector, and here's our 125 meter vector. Okay, have they followed the conventions we just outlined? The arrows point east, and they're different lengths. Now, do I need to bother measuring and calculating a scale every single time I draw one of these? No. Okay, you just don't need it that badly. Right. As long as they're somewhat to scale, like if you're drawing a 3 kilometer vector and a 6 kilometer vector and they're almost the same length, that's bad. Okay? You need to at least reflect the scale somewhat when you draw it, but you don't need to bother taking out a ruler and carefully drawing and measuring everything. That's wasting your time. You don't need to be that accurate. Okay? Your diagram is basically just to keep you on track. All right. Everybody follow how that one works? Okay, then our total displacement in this question would be 275 plus 125 would be 400 meters east. Okay, pretty simple. You would have done that stuff in science 10. Okay, that's addition of collinear vectors. What you wouldn't have done, likely, is draw the picture because, well, you really don't need to for one this easy. Right? We're just showing you how you would draw it if you were to draw it. Okay. All right, so collinear vectors, really easy. They just go tail to head. So does everything, but collinear really easy because they're all along the same line. Okay. So like we said, all vector addition is done by drawing the vectors tail to head. Okay, that is the second vector, the tail of the second vector is placed on the head of the first. We always draw them that way, okay, so that we're telling the story of what goes on. If we don't draw them that way, this is what I see people do. Okay? They say, all right, the object went 275 meters, and then it went 175 meters. What does that diagram say I did? Split in half. Okay? That's what that diagram says. It says you split in half, and half of you went 275 meters, and the other half of you went 175 meters in the other direction. Okay? That's not possible. Right? I have to draw this on the end of this one. Okay? Proper vector addition would be done by drawing the 175 onto the end of the first one. Everybody okay with that? All right, the perpendicular ones. I kind of drew one a minute ago here just to kind of show you what it looks like. Okay? But to draw or to add perpendicular vectors, we still follow the same convention. I draw the first line, in this case, 275 meters due east, and then I draw the next vector, which they told me is 125 meters due north. Okay? So I draw it on the head of the first. Okay, so here's the head of the first. I drew the second vector there. That's my 125 meter. Okay? All right, so now that I've got it drawn, the question is going to want to know what's the displacement, that's the red line, okay? And I'm going to want to know its magnitude, the length of that line, as well as its direction. That's this angle right here. All right, so to calculate the overall displacement, we just said a few minutes ago we would use Pythagorean theorem. Okay, so to calculate the displacement, right, I would go square root of 275 squared, a squared plus b squared, right? Okay, plus 125 squared. All right, so that vector is 302 meters long. Okay, and then I've got to calculate theta. Since I have all three sides of the triangle now, could I use any trig function I wanted? Yeah, I could use sine, cos, or tan in this situation. I would say go with tan in this situation for this reason only. If you screwed up this calculation, you'll still get the right angle using the numbers you were given rather than the number you calculated, just in case. I'm not saying you couldn't like reliably do a Pythagorean theorem calculation on your calculator, but okay, sometimes you punch in a number wrong. So what I would do is say, all right, I'm going to calculate theta, okay, and that's going to be, sorry, the tan of theta is going to be the opposite side divided by the adjacent side. Okay, so for me, that's going to mean theta will be tan to the minus 1 of 125, the opposite side, divided by the adjacent side, 275. Okay. All right, so I'm getting that the direction is 24 degrees. Which way? North of east. Okay, now, sometimes people get confused with how do I figure that direction out? Okay, here's how you figure it out. Your direction will always be measured from whatever primary compass direction your angle arc is touching. Okay, so this angle arc is being measured from east, and it's going north. Okay, so it's always going to be, in this case, north of east. Okay, if I had this angle here, okay, this angle would be south of west, right? Because this would be west, this is south of west. Everybody follow? All right, so this one's going to be 24 degrees north of east. So my final answer would be 302 meters at 24 degrees north of east. That would be my overall displacement for that vector. All right, perpendicular vectors, okay? It's just, it's nothing you haven't done in like junior high geometry. Okay? I guess you'll be able to handle that pretty well. All right. Tomorrow, what we're going to be looking at after our quiz, okay, will be vectors that go like this. Okay, paying attention still here, please. Okay, so tomorrow you're going to get two angled vectors and have to calculate what the overall displacement, that would be this line, will be as a result. That's where we're headed to. Your quiz will be posted by 3:30 today. Make sure you check Google Classroom tonight and do the quiz questions for tomorrow. Okay?